Hello guys, so in this video let's gonna talk about SHAP, okay, or we can say Shapley analysis. Now in this video I'm gonna mainly cover about what is SHAP, and why is it used, okay, and in the last of this video I'm also gonna talk about how do we visualize SHAP, okay, and in the future videos I will also talk about tree SHAP and deep SHAP, okay. So let's get started. First of all, why SHAP is used? So SHAP is used mainly for feature importance, okay. So feature importance. Okay, now let's try to understand this with an example, okay. So let's say we have one data set, and the data set has many features like feature 1, feature 2 and so on, and let's consider one feature as contact type, okay. And this contact type includes two categorical variables. One is humans, okay, and the other one is automatic, and there is one output variable that is whether the customer took term deposit or not, okay, and this is categorical variable either 1 or 0, okay. Now basically what this data set explains is we have multiple features, let's say age, gender and salary and other type of features, and basically we need to predict whether the customer takes term deposit or not. Some people say term deposit and some people say fixed deposit, okay. Now there is one feature called contact type, okay. Contact type humans means, let's say we will get some calls, right, like some people will say and talk to us stating whether you are interested to take term deposit or not. So those comes under human type of calls, okay. And automatic in the sense like we will get some automated call saying like press 1 to take term deposit or something like that. We will get automated calls, right. So those are automated calls, okay. Now if we use SHAP, let's say we build some model, let's say we build a XGBoost model, okay, by using this data set. Now let's say if we have some way that we can find out of all the features which one is the important feature, okay. Now let's say out of all the other features, contact type is very much important feature, okay. And also out of these categories, humans are giving good results. Like that means, let's say if you use a contact type as humans, then it is most probable that the customer will take term deposit, okay. And let's say if you use automatic contact type, then it is more probable that the customer won't take term deposit. Let's say if you could somehow figure this out from the model that we built, then we can spend more money on humans instead of spending automating everything. We can just hire few people. Or let's say if you get to know that this feature is not at all important, so that means whether you hire humans or whether you send automatic calls, it doesn't even affecting the term deposit. So the company will get to know that okay, it's not worth hiring people, so let's try to automate things. so you can make things in cheaper way. Okay, so let's say if you somehow get to know the feature importance, then in real world scenarios there is lot of importance. Okay, we can draw many insights from it. So this is how feature importance is very much useful in real world scenario. Okay, now let's understand SHAP. So basically by using this SHAP we will get to know the feature importance. Okay, now how exactly this SHAP works. Okay, let's consider one more data set. Let's say there are many types of advertisements like TV advertisements and some other advertisement like a radio advertisement and some YouTube advertisement. Okay, and some the output feature is obviously sales. Okay, now let's try to understand with this data set. Okay, now in this data set, okay, now I wanted to know what is the contribution of YouTube. Let's say by using this data set I trained one XGBoost model. So I am basically using this XGBoost model as an example. Of course you can train any other model like a linear regression, SVM or anything. Okay, now let's say by using this data set I trained one XGBoost model. Now okay, now let me explain how exactly we can find feature importance of this particular feature. Okay, now to find feature importance of this particular feature, let's ignore all this feature and obviously we don't need this. Okay, now let's consider these two features and let's try to write all the different permutations. Okay, now we have a TV feature and radio feature. Okay, now what are all the different permutations? Now you can take some empty set, and or else you can only pick a TV feature, or you can only pick a radio feature, or you can pick both the features. Okay, now what's the best thing that we can do? Okay, now what we can do is for this YouTube feature, okay, we will try to check let's say for this TV feature what is the output if we add this feature and if we don't add this feature. Let's say for this feature what happens if we add this feature and if we don't add this feature. Okay, now okay, now if we add this feature, let's say what if we add this feature, now the features will be TV and YouTube and the prediction we get is something like 10. Okay, now what if we don't add this feature? Okay, now we will be having only one feature, that is TV, and now the predicted value is somewhere around 8. Now if we separate these two things, now this is basically the feature importance. Okay, now so basically this thing we will repeat for all these variables. Okay, so all these permutations basically. Okay, now let's say for empty data set we are adding YouTube. Okay, now we got some value. Okay, and for empty we are predicting via just empty data set. Now we got some value. Okay, we will find the difference. Okay, and for TV also, as I said, for TV I will add YouTube, and for TV I won't add YouTube. Okay, for this one we will get some value and for this one we will get some value and we will find the difference. Okay, and for similarly for radio, okay, we will add this YouTube feature. Okay, and we will get some value, and for radio we won't add this feature. Okay, and again we will get some value, and we will separate these two values. Okay, now to find the feature importance, the best thing that we can do is, so whatever values we get here, we can just take the average of all these values. Let's say if we get h1 and h2 and h3, and for this one also we'll get h4. Okay, now basically h1 plus h2 plus h3 plus h4 by 4, this is basically the feature importance. Okay, now this is kind of intuitive. Okay, so basically what are we trying to do? So let's say if you want to find the feature importance of this particular feature, we are completely ignoring this feature, and we are finding all the permutations of other features, and we are trying to add this feature for every permutation. Okay, and we're checking all the possibilities basically. So one time we add this feature to this, and one time we don't add this. So if you find the difference, so that means we will get to know how important this feature is. Okay, so basically let's say for this example, okay, if we add this feature, it is performing even worse. Okay, or if you don't add this feature, if it is performing little bit good maybe. Okay, so by this way, if we just separate these two, we will get how important this feature is. Okay, and this feature importance can be in both ways. Okay, it can be positive and it can be negative. Okay, positive importance is nothing but it is helping it in positive way. Okay, let's say these YouTube advertisements are increasing the sales. Okay, if it is in negative way, that means it is decreasing the sales. Okay, now this is how we find the feature importance. Okay, now here the main question that comes is, let's say again we consider the same value, TV, radio, and what else, yeah, YouTube. Okay, and sales. Now we already trained one model. Okay, SG boost. Okay, now how can you just let's say consider one scenario. Okay, consider radio. Okay, for radio I am adding YouTube. Okay, and I am not adding YouTube. Okay, and so basically you will get one value and you will get another value, and you will separate these two values. Okay, this is how you will do, right? Now the thing is, see, let's say if you want to get a prediction of this particular value, now what are all the features we have? We have radio and YouTube as features, but we don't have TV feature. See, let's say if you train one model, let's say if you train one SG boost model, now we need all these three features to predict the output. Okay, we can't just predict the output with just two values, right? Okay, because the model is trained on all the features. Okay, now how do we get how do we remove this feature? Okay, so to remove this feature, let's say if this is a categorical feature, the idea is very simple. Let's say in categorical feature, let's say if it is a one hot encoded feature, it will have only two values, right? 0 and 1. Okay, now let's say what does the 0 denote? Okay, so let's say if you are saying 0, that means this feature is not there. Okay, 1 means this feature is there. So if you just keep 0, and then that means we are ultimately removing this feature. Okay, but here in this particular scenario, TV is not a categorical feature, it is a regression feature, like I mean continuous feature. Okay, now how do you remove this particular feature? Okay, so to do this, how we will do one smart trick, that is we'll have a lot of data, right? Here let's say this is our original data set. We have n number of rows, right? Now what we will do is we'll pick one row. Okay, and see, so basically initially we will calculate SHAP value for one particular row. Okay, now let's say consider this as 10, 20, 30 and 40. Okay, I'm just giving you some random example. Okay, now let's say if you want to find out SHAP value for this particular row, so what we are trying to do is we wanted to predict SHAP value for this particular feature and this particular row. Okay, of course we will again repeat the same process for all the rows, and we will just add this. Okay, so to get the total SHAP value for this particular feature. Okay, now to get the SHAP value for this particular feature and this particular row, so basically for this particular thing, what we will do is, so initially we will take all the features. Okay, now we have 10, 20 and 30. Okay, now we want to remove this feature. Okay, now what we will do is we will just randomize this. Okay, and how do we do this? Let's say in original dataset we have some other variables. Let's say for TV there are other values like 12, 14, something like that. So randomly we will just make it 12. Okay, and then we will pass this to the SGBoost model. Let's say this is SGBoost model. Now we will pass these three values to the SGBoost model. We will get one output. Okay, so this is Y-Pred. Okay, now again we will use one more variable, one more value, that is 14. Okay, now again we will cancel this, we will put 14, and again we will predict using SGBoost model. We will get Y-Pred. So basically we will repeat this process for all the values that are present in this data set. Okay, now whatever values we get, so we will just let's say we will get Y-Pred 1 and Y-Pred 2 and so on. So basically we will just take average of this. Okay, so what happens if we do average of this means, so basically we are trying to remove this feature and we are trying to predict the value using only these two features. Okay, now whatever value we get, so ultimately after doing this we will get some value, right? Let's say this is it. Okay, now again we will do this for these two features. Let's say we only care about YouTube feature and we wanted to randomize these two variables, TV and radio. Again we will do the same thing, we will take these two values. Okay, so we will take a 10, 20, and again let's say if we have other variables like let's say if we have 13 and some other values. Okay, so basically, so this is our original data, right? So we don't use the original data, we use other variables like 12, 13. Okay, but this will be same. Okay, this particular value we don't change. See, this is the original sample we wanted to predict, right? So basically in this original sample we will only we will fix this value. Okay, and we will randomize the other two values. Okay, same we will do 12, 13 and let's say 14 and some 16. We will again get Y-Pred 1, Y-Pred 2. Okay, and we will take average of all these things. Now here what exactly we get? Okay, so we get values for radio and YouTube and only YouTube. Okay, now okay, so this particular x is nothing but the value that we get when we use only these two features. Okay, and let's say we took average of this one also, and that turns out to be some y. Okay, now for this one, as I said, we got x, and for this one we got y, and basically we will separate these two things, and this is what exactly I said before. Okay, so basically we will add something and we will don't add something. Okay, so here if you observe, for radio variable we are adding YouTube, and for radio variable we are not adding YouTube. Okay, and we got two values and we will just compute the difference. So this difference is nothing but the SHAP value. Okay, now let's try to understand it clearly what exactly we are trying to do. Okay, now let's say we have three variables, right? TV, radio and YouTube. Okay, now we are trying to find, we have different data points. Okay, now 10, 20, 30. Okay, so for this particular data point we wanted to figure out what is the SHAP value. Okay, so basically we are trying to figure out the SHAP value for this particular feature and this particular row. Okay, now for finding this particular value, what exactly we will do? Okay, so basically we will find all the permutations. Okay, so for 5 we will add YouTube feature, and for TV you will add YouTube feature, and for radio, and for TV comma radio. Okay, so for these all permutations, okay, we will do both things. Okay, we add this feature and we don't add this feature. Okay, now I already told you how to calculate this one. Okay, now in here I already told you how to calculate by adding this feature and by not adding this feature. So basically we will just randomize things. Okay, and okay, let's say, as I said, this is x comma y. We will just separate these two, and we will get some value. Okay, and this is for SHAP for this particular thing, this particular permutation. Okay, now we need to repeat this for all the permutations. Okay, so basically just to not confuse you, what I'm trying to do is, for all the permutations I am just adding and I am just not adding, and while adding I will get some value, and while not adding I will get some other value, and basically I am just computing the difference, and this difference is nothing but SHAP value. So basically this difference denotes how important this feature is. Okay, now we will repeat this process for all these values. Okay, now we got value 1, value 2, value 3, value 4 for all these different permutations. Okay, now what we will do, we so our normal thought is we can just add these all values. Okay, v1 plus v2 plus v3 plus v4 by 4. Basically we can just average these all values, but the thing is this doesn't work like that. Okay, so let's say for example, if we average all these values and we got some value, let's say SHAP final. Okay, so this particular final value just denotes what is the SHAP importance for this particular feature and this particular row. Okay, so these are just data points, right? I am again drawing this. Okay, so radio and YouTube. Okay, so finally this SHAP final is nothing but this value. Okay, now we need to repeat this process for all the rows. Okay, now here we did this for only this particular row. Okay, now you need to repeat the same process for all the rows. Okay, Now sharp final 1, sharp final 2, okay, you will get all these values, right? Now to get the feature importance of this particular feature, we need to just take the we need to just add these all features, okay, and so basically we need to take a mod of it and we need to add all these features. Okay, so let's try to understand why do we need to take modulus of this. Okay, so basically what this sharp value denotes, okay, so this sharp value can be anything, it can be positive, it can be negative. So basically if the sharp value is positive, then that means it is positively affecting the sales. That means if this particular value increases, then predictions will increase, okay. So basically this particular value is increasing the predictions, okay, or else this particular value is decrease in the predictions, okay. Now this is what this sharp value denotes, okay, but our agenda is to get the importance of this particular feature, okay. That can be in both ways, okay, whether it influences it in a negative way or whether it is influencing it in a positive way, that doesn't matter for us. We wanted to know how important this feature is, okay, for considering it in a model, okay. So for that we just need to take the modulus and we just need to add all these features, and if you do this, you will get the final feature importance, okay, of a YouTube feature. This is nothing but feature importance of YouTube feature, okay. Now there is some catch, okay. So to find this particular value, here we are just adding all these values. So basically we are just averaging this out, okay. But this should not happen, okay, and basically this doesn't work, okay. And if you do this, like what happens is, let's say there is some so we will be having sales also, right? Let's say we have some baseline prediction, okay, and the baseline prediction is 100. So basically what exactly is this baseline prediction, okay? Let's say this is our data, right? Okay, this is basically our data set, okay. Okay, now we have different sales values, like 10, 20, some 12, okay. Now let's say if you don't have any of these input features, okay, what will be the sales, okay? That is nothing but baseline prediction, okay. Now let's say if you don't have any idea of any of the input feature, what is your best prediction for predicting the sales, okay? This is your baseline prediction, okay. So to find this out, we just need to average all these numbers, okay. Okay, so this is nothing but 10 plus 20 so on by number of rows, okay. Okay, so this is nothing but a baseline prediction. Now let's say the baseline prediction is 100. Now here we are finding the sharp values, right? We are just finding all the permutations and we are just doing average of all these permutations, and now we get the sharp value of this particular row, right? Now ideally, let's say for this particular value, the sharp value is a and the sharp value is b, and for this sf1, okay. Now let's say if we add a plus b plus sf1, okay, we need to get and if we add baseline prediction also, and the baseline prediction will be something, right? Here we assumed it is 100. Now if we add all those things, it should be equals to wipe rate, okay. And this is kind of intuitive, okay. See, because see, this particular sharp value tells, okay, how exactly it is taking away from baseline. Let's say if the SHAP value is a plus 20, then that means from baseline prediction, due to this value, the predictions got increased to 20%. Okay, not 20%, 20 values. Okay, now basically, let's say the baseline prediction is 100. This value, due to this particular input feature, okay, due to this particular value, just because we are including this, it got increased the baseline prediction from 100 to 120. Okay, so this is what this particular feature tells. Okay, this is what this particular feature value signify. Okay, I mean SHAP value signify. Okay, now if we add all these features, obviously it should be equals to y pred, right? Now let's say if it is increasing the baseline value by 20, and it is decreasing by 20, and again it is increasing by 20. Now if we add all these things, like 100 plus 20 plus 20 minus 20, it should be 120, and this should be equals to y pred. Okay, and this should be equals to y pred. Okay, and if this is not the case, then the values that we find out doesn't even make any sense. Okay, so what happens is, after we find all the permutations, and if we just do the average, this won't happen. Okay, if we add all these features, it won't add up to y pred. Okay, we won't get this y pred. Okay, so that means there is some mistake in this procedure. Okay, and the mistake is, so to understand what's the mistake in maths, you need to understand something called a probability. Okay, so you need to have little bit understanding of permutations and combinations to understand this, but let me make things clear. Okay, now let's say if we have three features, a comma b comma c, these are features. Okay, now we are adding. Now let's try to find out what are all the different permutations. Okay, now a b c is one permutation, and a c b is one more permutation, and b a c and b c a and c a b and c b a. So these are all the different permutations, right? So we will be having 3 factorial permutations. Okay, 3 factorial permutations, that is equals to 6. So these are all the different permutations we have. Okay, now see, let's try to understand this as, initially we have empty features. Okay, initially we don't have any features. Okay, and these features are coming sequentially. Okay, now let's try to understand it in this way. We have one bucket. Okay, initially this bucket is empty. Okay, now all the features are coming to this bucket. Initially a come to this bucket, and then b come to this bucket, and then c come to this bucket. Okay, and for in this scenario, initially we have empty bucket, and a came to this bucket, c came to this bucket, and lastly b came to this bucket. Okay, now let's try to understand this. Now let's try to understand a as our YouTube feature. Okay, now let's consider a as our YouTube feature. Here in our example we are considering this feature, right? So let's consider this as our YouTube feature. Okay, now for this feature, if we add, okay, so now let's try to understand this. Okay, so initially let's say if we have 5, what is the probability that the next feature is a? Okay, so these are all the different permutations, right? So let's say if we have 5, after that a came 2 times. Okay, so out of 6 permutations, 2 times, this is a probability. Okay, now let's say we have b initially. Now what is the probability of a getting the a getting as a next feature? Okay, So initially we have B, let's say in this bucket initially we have B, and what is the probability that the next feature that adds into this bucket is A. Okay, now see, we have B and we have only this particular permutations. Okay, initially it is B and next it is A. Okay, now so that is 1 by 6. Okay, so initially let's say we have A, okay, so let's say initially we have C. Okay, and what is the probability that the next feature that adds is A. Okay, so initially we have C, the next element and that adds is A, and again we have only this row, this permutation, so the probability is 1 by 6. Okay, so initially let's say we have both the variables, what's it, B comma C. Okay, so initially let's say we have these two variables and A got added to it. Okay, now what is the probability of this? Okay, now let's see, these are the two features. Okay, here initially we have B and C and now A got added. Okay, of course the order of this doesn't matter for us. Okay, so initially let's say if we have B and C, what is the probability that A got added to it? Okay, so this is nothing but these two features, these two permutations. Okay, now this is nothing but 2 by 6. Okay, now again we will come back to this. Okay, so basically we consider, let's consider YouTube as A and these as B comma C. Okay, now by this time you get to know we just don't need to, we can't average these things out, but we need to add the weights. Okay, let's say for this particular value we got V100, so for this we need to multiply it with so let's say if we have 5 and A got added to it, and here we are considering A as YouTube, so the probability is 2 by 6, right? So we need to multiply this with 2 by 6. Similarly we need to multiply this with 1 by 6. Okay, and 1 by 6. Okay, so 1 by 6, 1 by 6, and finally this we need to multiply it with 2 by 6. Okay, so guys, don't get confused. Okay, so what exactly this weight represent is, what is the probability that let's say if we initially have no features and YouTube got added to it, what is the probability of that event happening? Okay, and initially we don't have we have only TV feature and YouTube got added to it, what is the probability of this event happening? Okay, so we need to also consider probabilities, right? We can't just assign equal weights to all these things. Okay, now if we do weighted average, so basically we just need to add all these things. Okay, now we this is nothing but weighted average, so this is exactly S final. Okay, this is wrong. Okay, so what I said, this is actually wrong. Okay, this is the exact calculation that we are going to do to get the S final. And again, what is this S final? This is SHAP value for this particular feature and this particular row. Okay, and we will do this for all the features and all the rows. Okay, so just to make it clear, this is our original data set, and from original data set and using our model. Okay, here we are using XGBoost model. Okay, this is basically trained model. Okay, so by using this data set and by using this XGBoost model, we are just calculating the feature importance. Okay, so ultimately we will get SHAP values. Okay, now as our first topics, initially I said what is SHAP and why do we need it. Okay, now let's talk about how do we visualize SHAP. Okay, now to visualize SHAP, there is one plot called Beeswarm plot. Beeswarm plot. Okay, this is B. Okay. Okay, there is no big reason why this is named like this, because and the pretty simple reason is it looks like, you know, some bees. Okay, if you look at the plot you will get to know. Okay, now how exactly these bees worm plots work. Okay, now we have SHAP values, right? We have SHAP values for TV, radio, and what else, YouTube. Okay, and obviously there is one output variable, that is sales. Okay, this anyway we don't consider. Okay, we have different SHAP values. Okay, so it is plus 20 and minus 12 and plus 16, and here plus 13 plus 17 minus 14, something like that. We have SHAP values. So basically these values denote how much it is this particular value is increasing the predictions from the baseline value. Okay, as of now it's clear, right? Now let's try to understand how Beeswarm plot looks. Okay, so in Beeswarm plot we will be having one mean value. So basically this is 0. Okay, and here we will be having different features. Okay, let's say in this three features. Okay, in these three features, YouTube feature is more important. Okay, so in this case YouTube will be in the topmost position. Okay, and let's say this is next important feature. Now this will be in second place. Okay, and now this will be in third place. Okay, now again, how do you get to know whether this is important feature or this is important feature? As I mentioned earlier, you just need to calculate the absolute sum. Okay, so basically what we need to do is, here we have different values, right? So basically we need to take mod of 16 and mod of minus 14. Okay, so basically mod of 16 is nothing but 16, right? And mod of minus 14 is 14. So basically we need to add all these values. Okay, so we will get one value, right? So that is nothing but the this is so basically we are just calculating the sum, absolute sum we are calculating. Okay, so this is nothing but feature feature importance. Okay, actually we don't just take the sum, I'm sorry, we will take the mean. Okay, we'll take the absolute mean. Okay, so basically we will add all these features and we will divide it by number of rows. Okay, and here also I forgot to say, we just don't add these things, we divide it by number of rows. Okay, okay, so basically we just add this and we just divide it by number of rows, so we will get the feature importance of this particular feature. So based on this value, so after we add and divide it by number of rows, we will get some value, right? So feature importance, feature IMP 1, let's say. Yeah, and for this one, feature importance of YouTube, let's say, and feature importance of radio, and feature importance of TV. Okay, so we will sort these three values, and based on that, we whichever is top, we will place this in top position. Okay, so this is how graph looks. So based on this mean absolute SHAP value, we will sort this. Okay, now in Beeswarm plot we have two dots. Okay, so what I mean, two dots. Okay, one is red dot and one is blue dot. Okay, so red dot basically signify higher feature. Blue dot signify low feature value. Okay. Now, let's say, see, it is something like this. Okay. The Beeswarm plot will be something like this. Okay, and here also we have some margin, like let's say this is minus 20 or plus 20, something like this. Okay, now this is for every feature. We will be having one dots plot. Okay, we'll have plot something like this. Okay, so let's say in these dots will be either red or blue. Okay, as I mentioned, these dots will be either red or blue. Okay, let's say if we have more red dots here, let's say if we have more red dots in this side, okay, these are red. Okay, so that means what it signifies is, so for higher values, okay, so as I said, red means high value. Okay, for higher values the feature importance is positive. Okay, so that means here consider this case. Okay, let's say for YouTube, if we spend more money on advertisements, then that means we are having more sales. Okay, so basically what I'm trying to say is, in original data set for YouTube there will be one corresponding feature, right? So here I said about original data set, right? So let's say this is original data set and here we have 30, and let's say this is the biggest value. Okay, let's say for the range is somewhere like 12 to 30. Okay, the range of this YouTube feature values is somewhere between 12 to 30. So 30 is biggest feature, right? Now the for bigger values the SHAP value is positive, and for smaller values the SHAP value is negative. Then if we plot this graph, what happens is all the red points comes to this side and all the blue points come to this side. Okay, so that means for higher SHAP values we have higher feature values also. Okay, so that means if we spend more on YouTube advertisement, then we are getting good sales. Okay, so this is the inference that we will get. Okay, so basically nothing, we have different points, right? We will compare these points with the original feature values. Okay, and we will plot the those points. Okay, let's say for this particular so for one feature it is so for 30, if it is plus 20, the feature importance is plus 20, we will plot one red point here. Okay, and for let's say 12, the feature importance is minus 20, we will plot a blue point here. Okay, now so if we have red points more on this side, then that means it is positively higher values positively influence the sales. Okay, lower values, and if we have blue points here, then that means lower values decrease the sales. Okay, and let's say if we have more red points here, okay, let's say if we have more red points here and if we have more blue points here, so that means for higher values it is decreasing the sales. Okay, the SHAP value is negative, that means it is decreasing the sales. Okay, so let's say for this feature, if we increase spend more advertisement on this particular feature, that is radio, it will reduce the sales. Of course that won't happen. If we spend more money on advertisements, obviously it will increase or remains the same. But let's say if the if we got something like this, then that means if we spend more money on radio, then that may sales are getting reduced. Okay, so we need to stop spending more money on radio. Okay, radio advertisements. Okay, now this is how you interpret the SHAP. And let's say if we have points far away from the mean, that means it is affecting the predictions a lot. Okay, that means if we spend more money on let's say if we have more points here, more red points here, far away from 0, that means if we spend more money on YouTube, we will get more sales. Okay, or let's say if we have red point somewhere close to here, okay, then that means okay, it is influencing. Like if we spend more money on YouTube, it will increase the sales, but not very much. Okay, so that is how you interpret the Beeswarm plot. Okay, so for you to get the clear picture of this Beeswarm plot, you can once refer it to Google. Okay, and the advantages of this Beeswarm plot is here you can't interpret the categorical features. Okay, see, since this is a continuous feature, we have red and blue values. Okay, red denotes higher values, blue denotes lower values, but categorical variables don't have any order, right? So they will be colorless in the original Beeswarm plot. So it's difficult to interpret the categorical variables. And also one more disadvantage is, see, disadvantages is one, it's difficult to interpret categorical variables, categorical features. Okay, it's difficult to interpret categorical features. And the second thing is we can easily interpret linear models. Linear, if we have linear correlation, we can easily interpret. But if we have non-linear correlation, it's difficult to interpret. Okay, so let's say if we have some red points here and some blue points here, and it's kind of mixed up. Okay, we have red points and blue points here, and we have red points and blue points here. So that means there is some non-linear relationship. Okay, there is no linear correlation, there is some non-linear correlation. So those kind of things we can't interpret using Beeswarm plot. Okay, non-linear, if there is non-linear relationship between input and output, then these things we can't interpret using Beeswarm plot. Okay, so for getting this non-linear relationship, we have something called dependency plot. And for interpreting categorical features, we can use Watts plot. But I'm not going to explain all these things, but you can refer it later. Okay, so this is all about SHAP, and let's come to disadvantages of SHAP. See, these disadvantages are for Beeswarm plot. Okay, this is for plot. Now I am saying disadvantages of SHAP. See, first of all, let's come to advantages. Okay, let's talk about advantages. The first advantages is it is very powerful. You can easily understand this via algorithm. So basically we are trying to find all the permutations, we are keeping removing, and we are checking all the permutations. So whatever value we get from this, we can rely on it, we can trust that value basically. So basically this is very powerful algorithm compared to any other algorithms. Okay, and the second advantage is it is model agnostic. So that means it will it will work on any kind of model. Like let's say if we here we trained XGBoost model, right? What if you trained decision trees? Or what if you trained a linear regression or a SVM or whatever it is? It works for every model, or any deep learning models, anything. Okay, so here we are not depending on any model's particular algorithm. Okay, Okay, now let's come to what are the disadvantages of SHAP. SHAP, okay. Now the disadvantages of SHAP are mainly time complexity. Okay. The time complexity for this is 2 power m. Here m is nothing but number of features. Okay. Actually, it's even more than that. The original time complexity is somewhere around 2 power number of features into number of rows into number of features, something like this. Okay, so it's even worse. Okay, and you can easily understand this via algorithm. In our algorithm, what exactly we are trying to do? So we are basically trying to write all the permutations, right? So let's say here we have only two features, okay, and we got four permutations, and we have, let's say if we have 50 features, we will get 2 power 50 number of permutations, we will get 2 power 50 number of permutations, which is worse. Okay, so this is the main disadvantage of SHAP. So that's why we generally don't use SHAP. So to tackle this, there is something called tree SHAP and deep SHAP. And as I mentioned earlier, we're gonna discuss about this tree SHAP and deep SHAP in maybe next videos. Okay. So basically, this tree SHAP is for SG Boost or any tree based models like decision trees. Okay, this tree SHAP doesn't work for every model. Unlike SHAP, as I said, SHAP is feature agnostic, right? So I said SHAP is feature agnostic, right? So unlike SHAP, this tree SHAP doesn't work on all the features, all the models. Okay, okay, it will work on only SG Boost, decision trees, random forest, or only tree based models. Okay, but this yeah, again this D SHAP also works on only ANN based models. Okay, only it works on only ANNs and those kind of models. But the advantages of these is it has very less time complexity, and this is practical to use in our daily life scenario. Okay, so this is all about SHAP. Okay, so if there are any improvements or any suggestions, you can keep it in comments. Okay, thank you.